Hello, everyone. Um, First of all, I think I must thank Min and the team for inviting me here. It's wonderful to be in Kuching, and I'm very happy to make this presentation. Today, I thought I would speak about an idea that has always been important to the work that we do in Sri Lanka, both in practice as well as in research. That is about the context and conditions of labor in the construction industry and the impact of that in the whole process of building production, especially in countries like Sri Lanka, which I guess are still developing in so many different dimensions. First, I have to tell you that I have a very small practice in Sri Lanka. It's a young practice as well, in the sense that it's about 6 years old. And the work that I'm going to present today are the ones that we have done during those 6 years. But I'm going to use the work as an opportunity to discuss an idea about labor, work, and architecture. If I have to summarize Sri Lanka in one sentence, I would say that it's a place of extremes. We have a beautiful natural landscape with green, lush mountains on one hand and a beautiful coastal line on the other hand. But that landscape is increasingly threatened by the forces of urbanization. Most of our small towns are increasingly transforming into these kind of continuous urban corridors defined by urban development, unplanned growth, noise, pollution, and substandard buildings. Most of these buildings do not really work, either environmentally or aesthetically. We have a history which runs up to about 2,500 years old, which produced this kind of monumental architecture. But our history is also tainted by internal conflicts. Those who are familiar with the recent socio-political history of Sri Lanka knows that we've just come out of a 30-year civil war. The war is no longer there, but the problems persist because problems are political, and seemingly we are not finding right solutions for those. We have an urban building fabric which is seemingly growing vertically, responding to the needs of multinational companies and urban rich. But right next to that, we also have informal settlements and informal constructions of urban poor. And if you look at the construction industry, 85% of construction workers are informally trained and informally organized. So we have a serious issue of skilled laborers, serious issues of skill building opportunities. And there is a kind of a reciprocal connection between the poor quality of workers and the poor buildings that are mushrooming in the country. There's also a kind of a misallocation of intellectual effort in the industry. Professional and industrial actors have largely ignored the spatial needs of the poor and allowed proliferation of informal settlements as a kind of a social pressure releasing mechanism. Public housing, which was traditionally seen as government's responsibility, has not risen up to the challenge. Market-based commercial development, on the other hand, is highly supported by government through tax cuts, zoning, and so on. And architectural production, unfortunately, is limited to few individual buildings, often defined by hypertronage and top-end tourism. So what has happened is that the construction industry is sort of fragmented into different pockets of production with little or no reciprocal connection between labor training and knowledge dissemination. This has become difficult for all those informal actors who are starting from the bottom of the ladder to move across markets, learn from others, and develop socially as well as technologically. So in other words, there are seemingly technological barriers which prevents dissemination of knowledge across markets. So if there are technological barriers which prevents knowledge dissemination, then we will have to have technological bridges in the form of skill building opportunities. And our work in Sri Lanka looks at whether real building projects can be used as opportunities to train workers. Then from an architectural and design point of view, the argument is that if you use real building projects to train workers, then the building systems that we use should have plenty of tolerances and latitude for errors, and they should be inherently robust as opposed to being precise and sensitive. So what I'm going to do is that I'm going to go through a few of the projects that we have done in Sri Lanka, which different ways try to look at this issue in their own capacity. The first project I'm going to present you is a community library building that we built in a small town called Ambepussa, which is about 70 kilometers from Colombo, which is the capital city. It was a building which was built by a local regiment of army soldiers for the use of the soldiers as well as for the community, especially school children who live in the nearby area. One of the first things that we saw when we visited the site was that the army had been building a playground nearby, so there were plenty of residual earth, and the army has the human resource. So using rammed earth as the main building material became a serious option. The complex has three main buildings. The first one is the lending and the reference section. One in the middle, which runs up the hill, is a children's section, and one on the top is a research area. So part of the building sits on the earth using rammed earth walls, and the other part of the building floats above rocks using a recycled steel structural frame. And for the floor deck, we have used discarded railway sleepers. We want to be very sensitive in the way that we tackle the environment and the placing of the building. We didn't cut any trees on the site, so in a way that the building sort of meanders among the trees, and the idea is to create a series of indoor and outdoor spaces to accommodate the functions of the program. But as I said, one of the critical factors was the use of labor. And it was built by the soldiers, and there were few reasons why we use soldiers. One is that we didn't have a lot of money to spend on the project, so we didn't have resources to spend on skilled labor. Second is that after the war, we were left with this large workforce of soldiers who almost didn't have anything to do. So it became logical to retrain them in other trades and then use them in post-war reconstruction work. Third thing is that, especially during the last phases of the war, the government recruited a lot of young people to the army, and they didn't even had completed their formal education. The thing with the army is that when the soldiers reaches a certain age, say 35, they encourage soldiers to leave the army because army always want to recycle. They want to be young. So these kids who join the army without any formal education, when they were asked to retire, they don't have any fallback situation. So some of them become security guards, some of them even fall into the underworld. So the idea is that we use the building process to transfer trade skills so that when they retire, they can use those skills to build careers elsewhere. But again, the thing is that we didn't have money to train the soldiers first and build the building, so the training had to be done parallel to the building process, and that had to be planned. So these are some of the studies that we did to organize the training intervention. So this is a building of rammed earth wall. So we had to design the building system as well as the construction system, the joints and tolerances. We had to define the training ground, the production site, minimum working module that is required to have the training interventions, the labor structure for workshops as well as eventually to build the building, and the execution process, which eventually became the training steps. We call this diagram labor training matrix. So this is different building systems of rammed earth wall organized according to technical complexity. So you have the most simplest version of rammed earth wall, which is your typical geometrical wall. Then we are trying to connect two walls together perpendicularly. We are trying to taper the wall here so that we are trying to experiment with the shape of the wall. We are trying to connect rammed earth with other building systems. So this is about experimenting with the threshold conditions. We are trying to penetrate the wall to create openings. So the complexity of the system increases. The idea is that an unskilled worker can start building the most simplest version and then move up the technical ladder, acquiring the skills. And we have strategically incorporated these building systems in the building itself so that the construction process eventually become a kind of a skill building ladder. And we did this with other building systems as well. So this is building of a steel truss. So it's about, again, the design of the system, the planning of workshops, and the execution process. The skill building ladder, again, you have a very simple version of a welding joint where we are trying to weld a rebar to a steel plate. Here you have a complex welding joint where we are trying to weld an I-section beam to a steel tube. So an unskilled worker can start building the simple version and then move up the skill building ladder, acquiring the skill itself. So eventually, the construction process became a large skill building workshop. And we also tried to tap into the existing resources that were there. This is a kind of a welding plant that the soldiers already had. They were building these bed frames in steel, using steel angle sections. So they had the welding skill at a very basic level. So it was to tap into that resource and then develop them into a point where they can then eventually build the building. But the critical argument again is that if you use real building projects to train workers, then the building system should be designed with plenty of tolerances. So if you look at the text of this wall, for example, you can see that there are different configurations. For us, it doesn't really matter. We like to think that the ethos of the building does not rely on the precision in the making, but rather it's about the scale, it's about the texture, it's about the way that the building sits in the landscape, and so on. Even designing building systems, like for example, you can see here, you have a roof truss, and then you have the ceiling line, and then you have the roof line, and they are not aligned with each other, right? They are overlapping, because aligning is difficult when you use unskilled workers. If they have made a dimensional error in cutting the truss, then that will be visible if we try to align them. But at the same time, we like the fact that when the building moves away from its body, it started to peel into layers. So most of these details they are partly pragmatic, but partly poetic. But at the same time, we didn't want to compromise the performance of the building. And when it comes to this kind of interventions, performance is all about common sense. You know, it's common sense to design buildings as narrow floor plates in the tropics so that you have plenty of cross ventilation. It's common sense to design buildings around courtyards and around trees so that the trees can shade the building. It's common sense to use a thermal mass so that the interior can be kept cooler. It's common sense to bring light wells and vent scoops and so on. It's common sense to raise the building so that you don't interrupt on natural water paths. Even designing the building system, we were thinking of the training interventions, and the entire building is built or the design as a replication of a portal frame structure, so that once you train the soldiers to build the portal frame, then they can replicate the building. But at the same time, you know, architecture is about color, it's about light, it's about texture, it's about shadows, it's about the building sits in the landscape, it's about, you know, indoor spaces and outdoor spaces. It's about framing of the landscape. It's about understanding space as a journey. It's about the scale. It's about the proportions. It's about the textures. It's about how you frame outside from inside. But it's also about people. You know, people who build the building as well as people who use the building. So idea is to create a social capital, which is the trained workforce, and the physical capital, which is the kit-of-part building system, and use this social capital and the physical capital to replicate similar libraries elsewhere. So that's the first building. Second one is a totally different context and procured in a totally different way. It's a house that we built in one of the residential suburbs in Colombo. This is the house, and you can see that it's a typical suburban landscape with different textures. We built this for one of our friends whose father was the builder, but he was not a formal builder. He's someone who was in the government sector for 20 years. He resigned and then set up his construction business. So the first thing that he told us was that he didn't have very good carpenters, he didn't have very good welders, but he has good masons. So using brick as the main material became a serious possibility, and we wanted to use exposed brickwork. So the building is all about its envelope. The envelope wraps around space, creating indoor-outdoor rooms. It projects out to capture light and ventilation. It has become a canvas for the play of shadows, light, and so on. Internally, the volume is carved out into different volumes. So, there are different spatial connections between different levels. There's always also an environmental function. The hot air can rise up and can be escaped through gap that we have kept between the roof and the wall. We have created a series of threshold spaces around the building. So this is a sort of a veranda that looks into a linear courtyard, which is shared by another building owned by the same client. These are some of the internal courtyards. That is the veranda again. So that's the dining space, sort of extend beyond the veranda into the garden. This is the entrance to the house. You enter into a sort of like a 3-story atrium space. This is looking at the same area from inside. So the building is designed outside in to inside out. But a specific character of the building is still the wall. And we have introduced a series of bricklaying techniques in the facade. Partly it's aesthetics, but there was also another reason. The reason being that when we were told that these masons were, they were in the industry for 20 years, that was true. But this is what they have been doing. So they have been building brick walls, and then they have been plastering. So once you ask them to do an exposed brickwork wall, there's a totally different set of skills. So we wanted to use the building of the facade as an opportunity to transfer skills to them and then build up their labor capacity as well. So what we asked to do was, we asked them to build first the walls that you would plaster, and then gradually took them through the building of the facade, and while doing that, creating opportunities for them to upskill their techniques. So, this is one of the early walls that they built. We asked them to first, build the walls at the back and then come towards the front. So you can see that here, they've been struggling to align the mortar joints. The reason, there are many reasons that they were not used to building such walls, but also in Sri Lanka, when you order a brick, say when you say 200 millimeter brick, it never comes in 200 millimeter. So it would be 201, it would be 199, it could be 195. And when you start building a brick wall from one end to another, it becomes difficult to manage the mortar joint. So they eventually learned that the tolerance need to be in the joint, not in the brick. But even though if you see this in the image, if you go there physically, that you would not necessarily notice these things, because there are so many other things that is happening in the facade, so that the labor errors are sort of camouflaged. So we like to think that there's a kind of a built-in robustness in the facade so that the labor errors are camouflaged. So at the end of the day, the final product is a sort of a byproduct of responding to these series of spatial, cultural, technical, and social conditions. Third project is a department store that we built in one of those commercial streets in Colombo. So that is the building. When I say department store, this is not your high-end department store. This is sort of the bottom end. It is catering to low and middle income groups of the society. But you can see that most of the buildings in the neighborhood are fairly badly built, badly serviced. Most of them are glass block buildings which do not really work in the tropics. So we wanted to respond to the sort of the informal, chaotic character of the streetscape, but we also wanted to improve the typology. So what we did was, so we wanted to extend the street into the building and then design the building itself as a street. So we created this sort of large atrium space and introduced ramps to connect the different floor levels so that the street, physically as well as metaphorically, runs through the building. We project the top part of the building from the street level so that the glazing at the street level is protected. We reduced most of the glass in the facade and introduced these windows, and we tilted these windows to cut off the western sun, and we tried to bring light from the top. And the tilting of the windows also have created a kind of a nice urban experience along the streetscape, because when you move from one part of the building to the other part of the building, or the other side of the building, the facade sort of reveals a different facet. But at the same time, there was, again, an impact on labor. So what happened was the owners of department store had a chain of department stores, and they've been relying on these kind of informal work gangs to build their other department stores, and they had an economic advantage of using those workforce. So they were adamant that we should seek the economic benefit of that. So we said that it's fine, we'll use the economy, but at the same time, if we trigger a series of training interventions, we'll have the benefit of economy, but we will also have a better product. So that again triggered a series of training interventions, and in this instance, it's on concrete casting. So the fabrication of the system, their formal composition, and the eventual spatial condition of the building were all tied down to subsequent training aspirations of the project. So this is what we've been doing from rammed to steel to brick to concrete. We've been initiating different training interventions, not only to improve the labor skills, but also to give us an opportunity to build better products. There have been other connotations of labor in our work. I will quickly go through some of other examples. This is a small chalet that we've been asked to build in one of the beautiful parts of the country up in the hills. There were two issues. One is that the access road was very narrow. This is just one-way road. So this is to take to the hotel, and from there onwards, you have to walk through these narrow footpaths to access our site. So we have to respond to the limitations in access. Second one is that we wanted to design the building in such a way that once the tourism activities are terminated, we can dismantle the building so that the plantation can grow back. So we want to design a sort of a prefabricated modular building, but the problem is that in Sri Lanka, we don't have an industry of prefabrication, especially in those rural parts of the country. So what we did was that we got a local welder, and we designed the building in such a way that 80% of components can be built in its backyard, transported to the site, and then fabricate on the site itself. So this is a kind of a deviation from the standard practice, because welders in Sri Lanka are what we call journeyman welders, that they move from site to a site. They are site specific, and when they move from site to a site, they take their plants, labor with them. So because of that, they can't do multiple work. So the idea is that if they can fabricate at least 80% of components in their front yard, then they can do multiple work. So eventually they built this structure in 2 weeks, and the rest of the building in another 6 weeks. So everything is modular construction, even the windows, so you can take them apart. Other than this few retaining walls, the entire structure can be taken apart. There's kind of a scenographic effect in the building, responding to the program, because it's a touristic thing. But there's also a complexity in detail, because complexity allows us to upskill the workers. So at the end of the day, it's about responding to a particular program and the demands of a particular landscape, but also to see whether we can use that as an opportunity to reorganize the industry in a certain part of the country. This one also has an interesting story in terms of labor. It's a series of locker rooms that we were asked to design for a cement factory in northern Sri Lanka. Again, it has a very brutal landscape. It's a cement factory, so it's concrete and steel. But being a cement factory, they had one material available, that is cement. So we thought of designing the building as a sort of a kit-of-part system of cement components. So, perforated grills, sandwich panels, portal frames, walls and so on. But also we wanted to bring a certain environmental response to the building. So natural ventilation, breathing walls, greening of the facade and so on. But in terms of labor, what happened was that the cement factory is owned by a European owner, and they have very strict labor standards for their workers. So we said that, look, similar labor standards should be brought into construction workers as well. So typically, 90% of construction sites in Sri Lanka are like that. So we insisted that, why don't we introduce a better safety standards? So they agree with that, everything is fine, but there was a problem. The problem was that when the local contractors budgeted with the labor standards, the budget pumped up to 30% more. So it was not only the helmets, the harness, the boots, but what the contractor said was that the workers are not used to having these safety standards, they take more time to finish the building. So we had three options. One is to go back to the client and ask for more money, which we did, and they just said, piss off, we are not going to give you any more money. Second one is to tell them, look, forget about the labor standards, we'll just do our architecture. And third one was for us to compromise, and compromise is what we did. So we got rid of a couple of portal frame structures. We cladded the building with this very cheap steel material, which was found from the site itself. And then we did this graffiti to celebrate workers. But we didn't compromise on our light wells. We didn't compromise on our threshold spaces. We didn't compromise on the shading. We didn't compromise on cross ventilation. So, we still think that we have a nice space given the kind of the building. I mean, this is just your ordinary, changing rooms for cement workers, but we have opportunity for cross ventilation. We have plenty of views and natural light. Even the washrooms, upper level washrooms have light coming from the top. Ground level washrooms are opening out to the courtyard, so we didn't want to compromise on the performance. Last project I'm going to show you is again a totally different type of a project. This is a kind of series of reading rooms that we are building for a primary school, again in the center of the island. This is all based on volunteer work. The parents of the kids build it, and they are mostly farmers, so it's a very slow process. They only come to the site when they don't have any work on the farm. So what we did was that we went to the school, we spoke to the kids, we spoke to the farmers, the parents, and the teachers. Then we introduced these sort of training workshops. We brought some of the parents and teachers to Colombo, and we got involved in this research organization who helped us to initiate the training workshops. And then we went back and then start building, and everyone got involved, even the kids. So it's a collaborative process. It's a very slow process. Again, we are using rammed earth because it's economical, and kids love to work with earth. So at the end of the day, the building is as much as about the process as it is about the product, and it's about creating that opportunity so that everyone can get involved. So it's we are using rammed earth and then ferrocement, wall-proof structure, and so on. So very low cost, low skill construction system. So that would give opportunity for us to get everyone involved. So this is what we have been doing in Sri Lanka in a nutshell. This is not about continuing a style or a form, but this is about trying to understand specific context of specific projects and then try to come up with specific solutions. So every project is procured in a different way. So it's about being adaptable from the point of view of architectural approach. And something we would like to do is to develop a practice which can travel across different markets and then respond to different spatial and technical conditions. And we believe that that can be possible by having an adaptable and flexible language of work. This is, for example, how we have used cement across different building systems in different projects and different markets. For example, at the lower end of the market, we have used sort of lightweight prefabricated components using local manufacturers, ferro-cement, rammed earth, and so on. In the middle segment of the market, we have been relying on the conventional knowledge and casted objects like ventilated blocks and sandwich panels. And towards the high end, it's more about the refinement of casting. So this is not possible here. This is not needed there. So it's about trying to understand the opportunities and limitations that are projected in different building markets and then coming up with a solution. From a research point of view, it's also about how a singular practitioner can define the industry that they work for. So it's about coming up with design and building solutions which can adapt to different technical and cultural complexities on one hand and economical possibilities on the other hand. And that is, in summary, what we have been doing in Sri Lanka. Thank you.